Today, I thought I might talk about multimeters. Now, before you are a variety of multimeters, including one specialty multimeter that's only used for measuring inductance and capacitance. But beginning on the far right, you find what are called volt-ohm meters. Now, a volt-ohm meter just has a meter and resistors, switches, things, no other active components. So the only active component is the meter itself. So let me move over so I can zoom in a little bit on those multimeters on the far right. Here you see two very nice meters, volt-ohm meters. This is a Simpson 260. It is a vintage meter. This was considered to be one of this and the triplet, which I don't have displayed here, were the two considered to be the best volt-ohm meters of the day. Now, when I say that, I mean for service people. The one to the left is a kind of modern equivalent of this. Notice that I have a little sticker on it that says no bat. I'll talk about that in a second. But basically what these meters do is measure voltage and resistance and current. And in the day, these were considered to be the better volt-ohm meters because they had higher input impedance. And I'll talk about that in a second in a little more depth when we look at some of these other meters. But the reason that I have no bat is many of these meters use batteries for the resistance function that tend to decay over time and corrode and leak, and they can really mess up the inside of these meters. So in general, I do not keep batteries in my multimeters. Instead, if I want to measure resistance, I use a modern digital multimeter. But nonetheless, these can be very useful, particularly where you're adjusting something where you'd like to see the actual movement. For example, when you're tuning an IF transformer or you're trying to peak a circuit or whatever, it's much easier to do it with a meter like this than it is with a digital meter. Now, this one and this one are both high impedance. I think this one is 20,000 ohms per volt, if I remember right. And I know this one is. So they are fairly high impedance. Here are two meters that are smaller than the ones we just looked at. Both of these were made by Radio Shack. In fact, the one on the left was actually the first meter I ever owned. You may notice that over the years it got whacked on the corner there and cracked the meter phrase, but it still works fine. This is a 20,000 ohms per volt meter also, and I said I would talk about that, but before I do, let me mention this is 1,000 ohms per volt. Now, what does that mean? It means that the impedance that the meter presents to the circuit, we'll talk a little more about that in a little later in this video, but the impedance that it presents to the circuit, in a case of 1,000 ohms per volt, that means that if you are on the 15 volt scale, which is where I have this one, then you multiply that by 1,000. 15 volts times 1,000 gives you 15,000 ohms of input impedance. With a 20,000 ohm per volt meter, if you are on the 15 volt scale, this one does not have a 15 volt, but let's suppose it was on the 5 volt scale, you would multiply the 5 volts by 20,000. So this would have 100,000 ohms input impedance in the 5 volt range. Obviously, the higher the impedance, the less it loads the circuit. And the problem with loading the circuit is, suppose that there's 50 volts and you apply the meter and the meter loads the circuit down so it only reads 41 volts, and you think there's something wrong with the circuit. Well, no, it's just your meter is loading it down. Now, because volt-ohm meters do tend to load circuits, some new devices were invented, in fact, back in the 30s. And let me turn to a couple of those now. On the left is a polymeter made by Sylvania. On the right is an RCA senior volt-ohmist. Now, the senior volt-ohmist was considered a kind of an upscale service meter because it had this nice big meter and also some low voltage features and other things that made it desirable. But the biggest thing that VTVM did for you is raise the input impedance to, in the case of this, I think it's 11 megohms. At any rate, it's way above the input impedance of most volt-ohm meters. In fact, I think all volt-ohm meters. This device is an early vacuum tube voltmeter built by Sylvania. It's called the Polymeter, and it has some additional features. I'm not going to try to review this at this point, but if you're interested, a little later I will show you where you can get manuals for things like this RCA on a site called the Boat Anchor Manual Archive. So if you're interested in things like that, you might want to try to download that. Now I'm going to go briefly to some fairly modern digital multimeters. A digital multimeter's input circuit is very, very similar to the vacuum tube voltmeter. In other words, it tends to have a very high impedance, usually in the 10 to megohm or higher range. In general, this is not a review of multimeters, but what I wanted to show is that you can get some very low-priced meters, and you really only need one meter when you're starting out. I would recommend you not get one of these pocket type, not because there's anything really wrong with them, but you can get a lot more for the money in a little meter like this. This is a little Velleman that is frankly a good enough meter for someone starting out. I showed you earlier the little meter, the little micronta meter that I started out with, the volt-ohm meter. Well, if I were starting out today and I didn't want to spend much money, this is probably the meter I would start with. It only costs $7 or $8 on the internet from reliable vendors. I think it's like $7.95 from Amazon. And it has the high input impedance, just like the old-time vacuum tube voltmeters. It does have a digital display rather than the meter display. So at some point you may find yourself wishing to have a meter display as well. But when you're just starting out and you're trying to keep your investment to a minimum, a little meter like this, or one like this, or one that you've seen in some of my other videos that I think cost just under $20. The main difference between these are the first two, these two, you have to set the resistance reading yourself. And in fact, you have to set all the values. So for example, the DC voltage range is here, and then the resistance range and so on. And you have to set it with the switch. The advantage of this $20 meter is that it's auto ranging. And so here's basically the idea. If you just want the simplest little digital meter you can get, then a little one like this, and I'm not recommending particularly the Velleman, but what I am saying is a nice little cheap meter is good. For when you're starting out. You might want to go to an auto ranging meter because that can sometimes help you save making mistakes. And once again, for just under $20, you can get an auto ranging meter. I wanted to show you these two meters because these are the equivalent of the vacuum tube voltmeters, but these are modern meters that use field effect transistors in place of the vacuum tubes. The nice thing about this is they don't get hot, they tend to stay in calibration longer, and the FET provides the same high input impedance that you get from the vacuum tube. The advantage of these is they have the meter scale like the VTVM and like the old VOMs, unlike the digital meters. So these can also be a nice alternative, but I definitely would regard these as an upgrade if you're looking for a meter. Now let me give you a look at a specialty meter and another multimeter that you might want to consider. On the right is a Pros Kit LCR meter that will measure inductance, capacitance, and resistance. And one of the nice things about this meter is it has a pretty wide range of values that it can measure. The one on the left is another Vellman meter, which is a pretty good meter. Its downside is that you do have to set, it's not auto ranging, you do have to set the individual ranges. However, it has a pretty wide range of measurement values and it's not very expensive. It also has a nice power off function that if you forget and leave it sitting, it won't run your battery down, it'll turn off. Before I leave, I would like to mention a couple of other things. If you're doing audio work, you may want to consider purchasing a millivolt meter. Now, none of the meters I've shown you so far are really millivolt meters. This is a leader millivolt meter, and let me crank down here where you can probably see the legend a little better. You see, that's an LMV, I think it's 87A AC millivolt meter. And for measuring very tiny audio voltages, like you get off a magnetic cartridge of a turntable and things like that, you really can't beat a millivolt meter like that. They even make one that's a dual millivolt meter for stereo so that you can compare two channels. This one is not a dual. So I've talked about a number of meters here, and you may notice that nowhere in this group or any of the expensive Fluke or other Hewlett-Packard or other meters. All of these, and in fact most of them, are available used on eBay. So why is that? Well, there certainly are applications where a really nice Fluke 27 or something like that is indicated. But for ordinary servicing, like a radio, they are a bit of overkill. You're better spending, if you're going to spend those large amounts of money, you're actually better getting something like this bench multimeter here made by Keithley. Now this is a used model. It's the 415 THD. I think that's the model number. No, it's the 2015 THD, made by Keithley. It's more accurate. It stays in calibration. If you buy one of these used and you are buying it from a reputable vendor, they will probably calibrate it for you. Just be sure if that's what you want that you ask. And properly calibrated, one of these meters will give you that pinpoint accuracy that you get from a Fluke, but at much lower total cost, or better accuracy for the same cost. It's not that Flukes are overpriced. For their market, they're a good meter. But I think you'll find that if you're starting out in servicing, the thing to do is maybe start out with a small digital multimeter like one of these. Then when you get to a point where you want to upgrade to a digital meter, that you consider something like one of those over there, perhaps the one in the middle, because it not being the vintage, prized vintage Simpson is a whole lot less in price. You also might want to consider getting a VTVM. I recommend if you do not buy kit VTVMs. That is, VTVMs that were originally put together out of kits. A lot of them were well put together, but many of them were not. So I would stick to things like the factory assembled meters like this RCA if you want to go there. And also, you could, if you wish, consider, I think the meter on the left here, this meter, is no longer available, but I think this ECG meter, the FET43 is. That is a very nice meter that I think is even better than a vacuum tube voltmeter because it has the high input impedance, but because it's battery powered, it doesn't have any tubes, it doesn't have the heat, it's actually a better, longer lasting instrument. But nonetheless, the choice is always yours. So let me talk a little bit about some books you might want to look for as well, and then kind of wrap this up. Here is one of the better books I have found. It's from back in the day. It's written by John Ryder. It's available on the American Radio History Museum website. This is the title or the cover of the original edition. There also is a second edition, which I think is also available on that same website. There is a Gernsback book, How to Get the Most Out of Your VOM. That's volt, ohm, milliamp meter, in case I forgot to mention that earlier. Another Gernsback book that I have found useful is The VTVM by Reese Samuel. This is the Gernsback Library number 57. Once again, that one's on the American Radio History website. Here is a John Ryder book on vacuum tube voltmeters. Once again, this is on the website that's sponsored by AmericanRadioHistory.com. And finally, you might want to look for this book. I know I downloaded this. I don't remember where. It might be at one of the websites I've already mentioned, or you might have to just do a Google search. But this was published by Sylvania Electric Products, the people who made that polymeter that I showed you earlier, that monstrous thing that goes back to the early days of radio servicing. And this book has some of the best and easiest to read descriptions of things like input impedance and so on that I have seen. So look for these books, and I told you that I would mention a little bit about input impedance. So let me do that and then wrap up this look at multimeters and their use in servicing radios. Before I show you the Boat Anchor Manual site, I thought I would point out that in the bookshelf on the American Radio History.com website, there is a section on electronic servicing books, and in there is the Allied Electronics Data Handbook. I think in a previous video I may have indicated that you might have to search elsewhere, but that's definitely available on there. And then a book that I'm going to mention in this video segment a little bit more is How to Use Meters. That's also there, as well as two radio servicing books that you might want to look at. One is Radio Receiver Servicing over here, and the other is Radio Servicing, this one right here, which is a 1936 publication. This one is a 1959, the Radio Receiver Servicing. So I thought I'd show you those as kind of a supplement, and then let's go look for the Boat Anchor Manual's website. Here you see I've entered Boat Anchor Manual in a Google search, and the very top one there, Boat Anchor Manual Archive. And notice it says BAMA. That's just the first letters of the term at the top. .edinburgh.com. That is the major boat anchor manual source, but I will tell you that there are other places that do clone the boat anchor manual archive. So you see here what we have are directories. And so, for example, if I want to get that Sylvania, I'll check on that, and then let's see if, well, let me use a different one instead. Let me instead use RCA for that. I think it's the WV98. Yeah, that's the one. Okay. And here you see the senior volt ohmist, the WV98B. But you basically get the idea. Once you get to the boat anchor manual site, that is bama.edibri.com, then you find the manufacturer's name, click on that, and then under the manufacturer's name you find the model that you're looking for. So this site is a really good source for service manuals, particularly for test equipment and things of that sort. Don't try to find service manuals here for TVs or radios, but for service equipment, this is sort of the preferred site. At any rate, I hope this helped people if they haven't been able to find this site before. Once again, Boat Anchor Manual Archive. This is an old slide that talks about why you want the internal resistance of your voltmeter to be much larger than the circuit you're measuring. So it shows a battery connected to three 100,000 ohm resistors. So in other words, the battery sees a total resistance of 300,000 ohms. If you haven't learned Ohm's Law yet, basically when you put resistors in series, they add up, and the current is just the voltage divided by the resistance. I equals E over R is the way it's written. If you connect a voltmeter here, as shown on this side, the coil and multiplier inside the multimeter, this is the coil of the meter itself that drives the meter upscale. The multiplier resistor is the resistor that sets the sensitivity of this meter. If you assume that your voltmeter has 100,000 ohms of impedance, well, when you put it across this 100,000 ohm resistor, it's as though you changed the value of this resistor to 50,000 ohms. So now the battery sees only 250,000 ohms. And if you are using a higher impedance circuit and a lower impedance meter, it's even worse. So this is the reason that you want to have as high an input resistance to your meter as you can. Now there actually are ways using bridges and other balancing techniques to increase the input impedance to arbitrarily large values. But for the basic serviceman, I suggest that particularly if you're buying a meter today, you get an inexpensive digital multimeter that has a high enough input impedance. Generally they start at about 11 meg, some go higher. But that is very useful in virtually any radio circuit you might encounter. Vacuum tubes are inherently high impedance, so a meter that works pretty well on a transistor circuit may have problems reading accurately in a tube circuit unless it has a high input impedance. I hope you've enjoyed this little overview of multimeters. The main thing that I'd like you to take away from this is, first, there's a lot of multimeters. And there are some specialty meters and there are some general purpose meters. But in general, I suggest you start out with a relatively inexpensive meter. You won't have to throw it away when you upgrade, because you'll find that often you want to measure more than one thing in a circuit. And your little cheapy multimeter is still useful, for example, to monitor the B+ while you're checking bias levels with your new vacuum tube voltmeter or whatever. So you don't really need to worry about wasting money, but you can wind up wasting a lot of money if you buy a meter and pay a lot for it and then realize it's not exactly what you want. For example, if you go online and you're hoping to get something like this, and instead you buy something like this, while this is a very good meter for a very narrow purpose, it's not going to be able to do the things that you're going to want out of that RCA vacuum tube voltmeter. So, as I say, I hope you've enjoyed this, maybe learned a few things. In future videos, we're going to show how we use a meter, and we're actually going to start out using a little meter like this to measure first resistances, later voltages in a radio, and use that to troubleshoot. So stay tuned for more of the Frugal Repairman, and in the meantime, have a nice day.